of these patients die as a direct result. Essentially, bedridden patients lack substantial movement abilities, and this can lead to the formation of pressure ulcers and joint stiffening amongst other health-related complications. Pressure ulcers in particular, also known as bedsores, form due to shear forces or the constant pressure of bony areas against the surface, in this case the mattress, when the patients are now repositioned every 2 hours. So what is the current solution to this problem? Well, conventionally, caregivers are the ones that have to reposition the patients every 2 hours and move their limbs and joints periodically. But this can be quite physically taxing for the caregivers. So with this in mind, our goal for this project was to develop a comfortable system for residential bedridden patients, which will seek to minimize or reduce the risk of pressure ulcers and joint stiffening, while at the same time minimizing routine caregiver effort. So our main 3 functional requirements for this were, first and foremost, to make a safe system, and second, to meet a target cost between, say, $500 to $1,000 compared to other commercially available devices, and third, to allow continuous pressure variation. By this I mean a constantly alternating or wavy profile between, contact profile between the bed and the patient, and joint actuation, meaning that we could, for example, lift or flex and extend the knees by a larger scale, which is the key feature that our system is capable of doing, which other systems that are out there commercially available do not include.
So in developing a design for our project, we were looking at 3 main strategies, high-level strategies, including a pneumatic approach using inflatable air bladders, and then 2 electromechanical strategies, including an overhead gantry that can install over the bed and lift up the patient's limbs, or an electromechanical device that attaches either to the bed or below the mattress in order to provide either a roller underneath the person or have robotic arms dealing with the person's limbs. So we decided, in looking at these strategies, to what would be the benefits of each one. We decided that pneumatic strategy would be the best one for the macroscopic movements. We want to be able to move the limbs and joints of the patients, but at the same time, the rollers underneath the mattress provide that pressure modulation that some of the other products out there already provide. So we decided to eat our cake and have it too, and we created a device that incorporates both an air bladder and some rollers that go underneath the mattress that the person is lying on. So over here, as you can see, we're calling them tambourines because there's multiple, like a set of rollers that are installed, and they are on either side of the pillow. And this carriage that they sit on slides up and down the bed, and that is done by these belts that are on either side of the mattress. So these belts are driven by a motor through a system of pulleys. And another thing to mention is that looking at this right now, it doesn't look like somebody like your grandfather. You wouldn't want them to be sitting, lying down to this thing, which is why we have a memory foam layer on top of these rollers, because the rollers provide a very high pressure localized application, so the foam is able to spread out that area and reduce the total pressure that is on the person. So let's look at this linear drive system a little bit more in detail. The side belts that I mentioned before, they are able to drag that carriage basically by attaching directly to them using a plate that just lies between the two, the belt and the carriage. And the belts themselves are moved by applying a torque to this main shaft at the foot of the bed. This shaft is powered by a DC motor, and the way we spec'd out what we needed to do, we have a high estimate of 100 pounds is the amount of weight that this carriage needs to support at any given time, and that will probably be around the central area of the body. And using a very high estimate of friction, because even though we expect a coefficient of 0.2, we estimated high at 0.9 in case something happens that creates more friction than we expect. And using the pulley radius that fits the dimension that we're looking at, we came up with a drag force and the torque that needs to be applied to the shaft. Additionally, the DC motors that are supplying the torque to the shaft are able to do so using a 4-to-1 gear ratio belt pulley system. And the belts themselves are all tensioned by adjusting either the idlers or the motor position on the device. As you can see, many of these 8020s have a slot, so that you can either drag it up or down. Something that we found though is that in operating the drive system is that the tensioning that needs to be applied to this belt could be improved, even though we were able to sustain it at the level that we wanted. The device, the design itself could be improved in order to account for any changes in tension that we are not expecting. And then at the end, we were just picked out a motor based on the velocity that we wanted to operate at, which is very slow, about 120 seconds to move up and down the full scale of the bed. This over here, as you can see, is a small scale of the bed in order to make it manageable for this project. Over here is a video of 10 times the speed of how it operates, 20 times the speed. And so in the center you have a pillow that inflates using a hose and this pump over here. And something else to notice is that the pillow itself is pre-tensioned with elastic bands in order to deflate the pillow at the very end when we're of the macroscopic motion.
Cool, so the next thing we're going to talk about is the control strategy that we applied to the system and the electrical backend that provides. So the pump that is attached to the system is making this vibrating noise is attached to a servo mechanism that is attached to basically a valving so that you can controllably inflate or deflate the bladder, and then that is connected to a linear carriage as described to position it on their body. As it moves, it provides small scale motion and then the large scale motion from the bladder. So to control the motor, you have a basic motor controller, and then there's also a set of switches that can be used to detect the position of the carriage under the body, as well as to determine when it has reached the beginning and end of the system. And there are also 4 linear potentiometers that we use to generate analog inputs to the system. For the demonstration that we're showing, we're using a basic control to move the carriage up and down directly with potentiometers, as well as one of the potentiometers to control the pump. In the control strategy that was shown in the demonstration we had in that slide, and will be on the next slide, it is slightly more involved, where it essentially starts by calibrating to the bottom of the bed, and then from there it continuously moves up and down the bed forever. And as it moves up and down the bed, it senses whether or not it has made contact with one of these predefined regions. If it is at one of those regions, it determines whether or not we would like to activate the bladder at that point based on user input, and then it engages an inflate-deflate cycle. So if you look at the next slide, this is an example of the system running under Julia that we conducted earlier, and it is moving up and down. It hits a point, it executes an inflate and then deflate cycle. And as it moves up and down, the caregiver or person who's using the system can modify the potentiometers to define whether or not they would like a specific region to be actuated. And so you can see in the first run, it started at the lower leg region, and in the second run, it moved to the upper leg region to provide joint motion at different points in the body controllably. And after this animation, you can show that also has this motion as it moves back and forth and creates this wave profile. And that is a demonstration of our system, and Julie is currently laying on top of it. Conclusions from this project: we successfully made a system that is a scaled form of ultimately what we would like to do. So as you can see here, it's only providing motion under the legs because we wanted to make something that was somewhat more portable than a full bed. You can easily scale this to a full length of motion, as well as make it wider so that you have 2 bladders on either side of the leg to provide separate joint actuation. Additionally, we managed to meet all of the functional requirements that were given. The ultimate cost of this system and materials is slightly higher than our budget. However, there are a number of things that we could do to reduce the cost, and a lot of that was mostly due to just trying out a couple of different things as we were doing our prototyping. Thank you. I'll turn this off for now.
Yes.
So we did visit the Boston home as part of our determining some components for the system, and they mentioned that one major area of concern for caregiver input is to leg motion. And that was part of the motivation, is providing some ability to provide a lifting and lowering motion, which could reasonably provide that kind of support. I don't know if there's any.
Yeah, one of the things they told us is that being able to raise the leg, or even just like actuate the joint at the knee, would be something that would help tremendously.
Yeah, so you talked about your different strategies and you decided to have the cake and eat it too, and do both. Can you give a sense of like the cost trade-off of having a motor, an actuator, a linear stage plus an inflation? And like how much better is the device because you have both compared to just having a couple of inflation things or one motor thing?
So as we mentioned before, or I think over here, the total cost of what we spent on getting this guy built was about just under $1,000. And yeah, for most of it, I think it was for the linear actuator. And one of the main reasons we decided to go for this approach is that there's already a lot of things out there in the market where what is being done is that there's multiple chambers, and then you just go back and forth between which chamber is inflated and not. So we wanted to go with something that was a little bit different, that would be, one of our aims was to go mid-level cost. There's some really expensive products out there that can even sense the pressure points on your body. So we wanted to go with something that
Even some of those like pneumatic solutions that are commercially available, they go like really high in cost, like $6,000 and even higher than that. And one of the major things that we wanted to be able to accomplish that they don't do is like joint actuation. None of those out there that are pneumatic solutions do like, you know, big deflection of like your knee, for example, or other joints. So it's just like smaller microscopic alternation of pressure. And with having the cake and eating it too, we were able to do both into one system.
Yeah.
Have you thought about using it provider?
Yeah, so the pump
Yeah.
is, the original pump was actually in an enclosure, and this was cobbled from another system, and it's significantly quieter when it's enclosed. We just didn't bother with that necessarily. But this is just a pump that is actually used for an equivalent type of system that has alternating air bladders, so we knew it would be within the specifications we wanted. But yeah, you can certainly reduce the cost. A lot of the noise in the system is that pump cycling, as well as the servo that we use for controlling pump positions is something we had, and that's kind of noisy as well. But both of those can be significantly reduced. Yeah.
I think one thing that was mentioned before was maybe that caregivers also need help for flipping patients. Does your device help with flipping the patient?
So that's something where if we had a set of parallel carriages in the full-scale system, you could reasonably do something where you tried to inflate just half of the patient, provide tilt. But I don't think that's necessarily something that was within the scope of what we were looking at directly. It was more looking at specific to joint motion and general pressure gradation as opposed to tilt. And that's something we didn't look at earlier on. Yeah.
Do you have any evidence right now to support the degree to which you're actuating the bed to reduce the pressure that causes bed sores?
So that is something that's definitely important to quantify. We didn't necessarily come up with a good way to measure that metric. Part of something David mentioned is there are systems to measure the pressure distribution. I believe there was actually a previous project in this class that looked at that. Commercial systems that do that are for thousands of dollars. To measure it on the more general wishy-washy just feeling of it, I know when we were testing it, it was definitely comfortable to lay on and you could feel some small-scale motion in your body. So that's not a very quantified answer, but
some of the areas where bedsores tend to be applied are right at the end of the lower back, and then also at the bottom of your feet. And when this pillow inflates, it basically lifts up your feet from the mattress, so that allows the blood to go to the feet, and that helps minimize the bed sores, essentially.
How is your memory offers supported? For getting in and out of the bed and
I'm not sure what you...
like, so you use a memory foam for like going up and down?
Yeah.
You go like, and then higher and low? Like, normally memory foams go on top of our flat surface. How does that work?
So, okay, part of what's happening here, you might be able to tell it's clamped on the ends, and what's actually happening is the entire memory foam surface is stretching slightly as it's moving up and down. And we didn't have anything here, but you would additionally have some sort of protection design so that you can't like stick your hand under the deflecting surface. But ultimately, yes, it's under tension at the two ends of the mattress, which is providing that. side here so that it acts as a bed.
And there's like a long one down there.
So the medical isn't supported by any underage tension?
Well,
No,
when
there's
it's
no
deflected, you can see that it's fully supported by the foam under. There's,
What about
if the,
when the pillow's not blown out, that would the patient fall into?
well, so that when it's deflected, when it's deflated, essentially the patient is laying on top of the plastic sheet. There's the carriage, but it's still quite comfortable.
And underneath that, there's all of this is foam as well.
I mean,
So
the goal
there's
would be for
direct
that.
support underneath as well.
The goal would be for the patient, even when you're not inflating or deflating the bladder, the goal is for that carriage to be like moving up and down from head to toe,